Welcome back to Garage 512, and I'm excited. Number one, I am going to be touring the LME facility. As you can see right here, I'm right up front in Houston, Texas. They are building me my brand new long block, 454 stroker. Unlike the last one, which was an ERL short block, we're still using the the LS7 heads, ported, but still stock castings. This one is being built from soup to nuts with a LSR block, all aluminum LSR block, Callie's crankshaft, diamond pistons, comp star, connecting rods, and a custom ground cam. We'll see what the power is. It should be impressive. It's going to be running 13.25 to 1 compression. So it will, as far as, so it's going to be running 13.25 to 1 compression. So it will be exclusively running E85, so corn-fed. That said, let's go inside and tour the facility. We're going to meet my sales guy, Colin. He's going to tour me around the facility. We're going to get a chance to see my actual long block. It should be assembled, fully assembled this week, and go on the Engine Dyno next week. So let's go in and take a look and see what's what. Oh, if you didn't notice, I am pimping my my new Garage 512 shirt. I have a logo shirt now. The back, check that box. It's prototype. I'm going to put a check box in the middle of the back with a box around it. So stay tuned for that. You can order that once I get an online store and everything set up. But looking forward to going inside, checking out the motor, and let's see what's what. All right. I'm here with Colin, my sales guy over at LME. And I just delivered the MSD fuel rails because they need those for the intake that was finally shipped by Tony Memo, and we are going to go do a tour around the facility. He's going to show me what's what, and I'm finally going to get a chance to see my motor. So it's fully assembled now, huh?
We're at the short block stage, getting ready to put the heads on it. Had some engine builders going in and out at the moment, so we're not quite finished up with the long block, but we should be putting it on the dyno early next week. So,
awesome.
Yeah.
Awesome. Yeah, it is.
All right. This is our assembly room.
Wow, that's a big freaking motor. What the heck is that?
So this is our Godzilla. This is a Ford Godzilla that we've done a lot of R&D testing on. This is actually our dyno mule. So we've ran this with a bunch of different combinations on it, just going through and testing all of our Godzilla platform stuff. This is our cast front cover. It's a BBT delete front cover. It also allows you to put a different oil pan on it. We have front sump and rear sump oil pans. The Godzillas come with a jack shaft inside the oil pan for the oil pump, so it really limits your options on trying to swap it into a different vehicle. So we're making this to where you can swap it into a different vehicle. CVF kit bolts up to our setup really nice, and so yeah, that's kind of what we do for the Godzillas. It's got our awesome valve covers on here. This specific engine has our cam and CNC-ported cylinder heads. Makes just over 730 horsepower. It's a pretty good horsepower for a factory engine, essentially. I mean, putting a cam in it and pointing the heads, making 730, that's pretty impressive.
Yeah, it is.
So.
Yeah, so that's the MSD. Is everything in there that you need?
Yeah, yep, fuel rails are here, so we just need these so that we can run it on the dyno, and looks like you got everything here. So here's your injectors for them. You got injector dynamics injectors, so
Are these the which ones are these? The ID
1050s.
Okay, we talked about that, right? Because I said that because I remember I talked to my tuner, Pat G.
Okay.
And he's the one that suggested, I believe, that exact one. That's where you got that information from me, right?
Yeah, this is what we would use too, but yeah.
Okay.
Yep. So injector dynamics, they're super good injectors. They have a lot of data. Really good for everyone tuning. I've never met a tuner that doesn't like it. So,
yeah.
But yeah, this is your intake manifold that you got it all finished up. So we had it split apart the other day. Let's see if it's. Yeah, it seems like it is. Yeah.
That these plastic things don't melt.
They're made from a pretty good material. All right, there you go. So you can see the longer runner design inside the manifold right there.
These guys here.
And that's gonna be what's helping you pick up torque on the bottom end. You can see he goes through and looks like he ports the snout a little bit, kind of ports it in here, and then he goes into about that section of the port on the inside. So.
Oh, really? So, like inside of here, they poured it all the way inside?
You can see right there on the right here they go in.
Oh, here
into the ports. So they poured it until about right there. So it doesn't look like he does a whole lot out here. So if I had to guess, he's tested it and probably doesn't get a whole lot of gains if he goes in here. So I would imagine that most of your gains are going to be done in here to the front of the snout.
So the shorter runners that I've seen, like for instance that sheet metal one that you guys create, billet one, those are shorter runners, right?
Correct.
And those are mostly for force induction type scenarios?
Not necessarily. They're good for high RPM. So the shorter runner is going to be good for high RPM. The longer your runner, you're going to be making more torque on the bottom end. But this intake does have a lot of volume in it too, so that also helps out with the high RPM stuff. The MSDs and our intake are actually very similar as far as performance goes. How many more bearings you got, Cameron?
What?
I said, how many more bearings you got? I'm gonna wait for you. But
Oh, I'm sorry.
you're fine. You're fine. You're fine. But yeah, these perform really similar to the LME intake.
That's interesting. And so the advantage of the long runners are the fact that they produce more torque down low. And I think my stroker is going to make peak torque or peak power right around 4,800 RPM or thereabouts.
No, you're gonna be peaking higher than that.
Oh, really?
You're gonna be, well, I don't know. We'll just have to run on the dyno. See, I don't want to say where it's going to be picking at, but it's going to be quite a bit. We got a good sized cam in there, so
That's awesome. Okay. All right, so let's take a look at what's left. What goes on in this particular section?
So this is purely just an assembly room. So we don't do any machine work in here. You can kind of feel the temperature is always this temperature. Doesn't matter what year or what time of year or anything. It's always going to be this temperature in here because we want all of our clearances to be very exact. So if you have different temperatures and different materials are going to grow and expand and everything. So we want to make sure everything's always a controlled environment. So this is yours right here. Got your LSR here. You can see they're checking piston and valve clearance yesterday. So this is your cylinder heads. We got you set up with a set of CIDs.
CIDs are full on race heads, huh?
Yeah. So we get the castings in-house, and then from there we go through and do all of our own porting process. So we go through, we port them, we do the intake flange, we do the exhaust flange, and then we do some nice work here. Not everybody goes through and machines this. It's small stuff like that. That doesn't enhance performance or anything, but it makes it look a lot nicer.
It does. Oh, and I see that they're branded CID.
Yeah.
At the top. Can you angle it?
Yeah. So the CID is the casting company that we work with, and we do all our own performance and everything like that.
That's pretty. Yeah, when y'all ship this motor to me or to my shop in Austin, the plan is to ship the existing one back to you guys so you can figure out what the heck went on. What we suspect happened is it dropped a lifter, and the lifters and the heads were all replaced. I don't know, about a year or so ago, but I heard that 1 in 100, even if it's brand new, 1 in 100 lifters can fail, which is scary because then it just destroys every fucking thing in the motor. Ironically, based on the pictures I've seen, like I said, I only drove the car for 6 hours, but the pictures that I got from the previous owner are branded LMEs heads because it's written there, but they use those lifters that I told you about, and I guess they're okay lifters, but shit happens. But we're gonna ship that back to you guys in the same crate, and hopefully you can diagnose exactly what went on. If everything else is good, I'm pretty sure the internals are fucked. I know the cam is fucked. I know the MSD intake that's on there is melted because of the exhaust valve breaking. I don't know if the pistons and crankshaft are good. My guess is all that's crap. But if the block is good, then I can at least sell the block. right?
Yeah.
And anything else? You think what like your best guess? Like what do you think might be salvageable in a scenario where a lifter dropped?
I would say at best case scenario, your block, crankshaft, and rods would probably be the things that would make it out. Um, Usually not a whole lot of others make it out, and even then, a lot of times that stuff doesn't make it out, depending on how bad it is.
Yeah,
So,
fair enough.
yep.
Okay, so oh yeah, that's pretty good. So LSR, the block is made by what's the name of that company?
Concept Performance makes the LSR and LTI blocks.
Is there much difference between? I mean, they're all aluminum, like the RHSs, and they're all aluminum, right?
Yeah, so the three companies that make aluminum LS blocks is going to be Dart, LSR, and then RHS. So we prefer the Dart and the LSR blocks here. They're definitely the superior block for aluminum. Um, so yeah, that's what we prefer to use.
That's awesome. That's pretty. I've seen some of the old GM castings that are like orange. Is there a reason why they're like the block itself is like outlined in orange or whatnot?
Yeah, so those are LSX blocks. Those are going to be made directly from GM, and those are an iron block. So the orange is a powder coat that they do on there to preserve the metal of the block.
Yeah, they're significantly heavier. What, about 100 pounds or more?
They range from, depending on what aluminum block you're comparing it to, it ranges from 100 to 120 pounds.
Wow. Yeah, that's considerably a lot because this on the weight savings from the aluminum hydroform frame to the steel frame on the regular base six is about 126 pounds. So that's another huge savings. The stock LS6 is that iron? Is that also aluminum?
The LS6 is aluminum.
It is aluminum. Okay. All right. And what's this thing you got?
It's another LSR. So I don't know the exact combo on this one, but it looks like they're degreening in the cam and everything, getting ready for it. So um, yeah, I don't know exactly what they're building on that one. I don't see the build sheet,
Yeah,
but
okay. I was
yeah,
just curious. That's the one I care about. The
right.
physical size
Hmm.
um, is literally the same, regardless of what displacement,
Yeah,
like how much it's bored out and strode through, right?
yeah. The block itself will always be the same. It's just the only thing that'll ever change is the actual bore size and crankshaft size. So your bore size is a 4185. We went pretty big on the bore because we're just trying to get more power out of it. So um, more cubic inch, more power. So that's the route we took there. And then we also put a bigger stroker crankshaft in yours. We did a 4 and 8 stroke. So
4.8 or 4.125. No, I thought it's 4.125 now.
yeah, that's 4 and 8.
Okay.
Yeah, 4 and 25, 4 and 8.
So on the LSRs, are they considered re-sleeved?
They're not considered re-sleeve. The sleeves that they get in there are a nice darn sleeve. They're an aftermarket block that come with aftermarket sleeves. So the factory blocks will come with the sleeves casted into them. So they don't machine where the sleeve goes. On an aftermarket block, you can see there's the exact same amount of material of sleeve everywhere you look. If you were to look at an aftermarket block, or sorry, factory block, they put the sleeves in and then they put casting around it. And then after they're done, they'll go through and they'll go off and put the bore spacings in there. So if you were to look at a factory block, you can see where some sleeve would have more material versus other areas where it would have less material because it's a casted in sleeve. So they don't go and center off of the sleeve when they cut out the bore. They just put their bore spacing in the engine and put it in. So it can be not centered in the sleeve. That's why aftermarket blocks are always going to be superior to a factory block.
Okay, yeah, because my last ERL was a re-sleeved block.
Mhm.
They used the stock um, LS7 block and then re-sleeved it, I believe. Right?
Right.
Is that how they used to do it?
Mhm.
And I think my short block was fine. One of the lessons that I learned from the last stroker, also 454, was to not let so many fucking people touch it
Mhm.
because those heads, the stock LS7 heads, were worked on by 2 or 3 different people, and then each time, they're jacking with something with this block. Like I remember, like there's a cross drilled cam bolt, and some shit in there. And the last guy who worked on it fucked something up, and I had talked to what's his name over in Rear Morrison, engine guy, Darren Morgan, and he was explaining to me how to unstick a cam bolt. But the point is, there were so many people touching my motor. I decided this time around, yeah, it's costing me a ton of money, but at least you guys are fully building the entire long block. And the only people that are going to be messing with it is the shop you're sending it to over at CF Works in Austin, Texas. So that's my lesson learned. I can't tell you how many people just mess with the last car. I mean, it was like they would, these engine shops, they would do some performance work and then fuck something up, and then not want to warranty it, not want to take any responsibility, and then I go somewhere else and then they fix it, and then they fuck something up, and then and then it's this cycle. I'm like, no. So thankfully this time around, I think I've got great people. My buddy Justin, who had several cars and did all kinds of crazy shit for his different He's Monroes and Porsches and high-end stuff, and so I am now trusting exactly who he recommends we go to, which is why I'm at CF Works in Austin for the performance shop.
Right on. Yeah, and the nice thing about here at Late Model Engines when we build these is there's zero guesswork. We've been doing this for 20 years. This is our bread and butter combos. We know what we're doing. We've been doing it for a very long time, and we're going to test this thing. We're not just going to tell you that it's a good engine and send it on its way. We're going to put this on the dyno. We're going to make the power that we said it's going to make, and we're going to break it in for you. We're going to guarantee all the oil pressure. We're going to show that it doesn't have any leaks, and we're going to send it out as a quality product that you can use over and over again. So that's what you get when you're paying the little extra money. You're getting a proven product.
That's awesome. And heads bolt on here.
Yep, heads are bolt on. You have your valley cover right there. The lifters will go in right there.
Yeah, great. Intake manifold.
Yep, intake will bolt onto the heads once they're on there, and good to go.
That's awesome. Okay, so this is the assembly section.
Yep.
And the connecting rods and everything are already in there. These are the top star connecting rods, right? And they look like the ones you sent me a picture of. Actually, the difference.
Let's see. These are Manleys. Yep, that's a set of Manleys.
And these are what are these? Are they these guys here?
These are your piston rings.
Okay.
Yep, that's what rides on your cylinder walls and holds the compression into the motor.
Now with that particular SR, that's already pressed in, like from the factory, their factory, right?
That's the sleeves are. These are rings. So rings are going to go onto your piston. And when they go on there, they're going to compress. You can see that they compress. These have ring tension. Once they're in there, they're going to push out, because when you go in, they're going to be pushed in. And so once they're in there, the natural tendency is going to be pushed out against the cylinder wall. That's what's going to seal your combustion in your motor. So when these pistons come up, this is where your cylinder wall, or your cylinder is in the cylinder head. Your piston comes up, and this is where all your compression is going to be coming and pushing in, and you're going to have combustion inside here. And once it's done, it's going to leave through the exhaust valve, and after it goes through the exhaust valve, your intake valve is going to open up. That's what's going to bring in all your fresh air to create another combustion on every single cycle. So it's going to keep going over and over and over. So,
and this is the intake, and that's the exhaust valve?
Intake valve, exhaust valve, yeah.
Gotcha. What are they made of?
So your intake valve is going to be made out of titanium, and your exhaust valve is going to be made out of stainless. If we're doing a forced induction application, we would do the exhaust valve out of Inconel. Inconel. Yeah, it's a metal that withstands heat very well. In this application, you want stainless because you're not going to get as hot as you would on a forced induction application. And so in this case, we want to be as light as possible. So we would take, the Inconel is a little heavier, but in boosted applications, we would take a little heavier valve for strength purposes over this application where you're going to be naturally aspirated for lightweight purposes.
And on the stock LS7, they're sodium-filled exhaust valves, is that right?
I'm going to be lying. It's possible, yeah. The LS7s have a titanium intake valve. I know that. I don't.
I think they're sodium, yeah. And they're sodium because I remember watching they tend to stay with the sodium because on the C7s and the C8s, I think they mentioned they were also sodium filled. There's some reason for that. I guess lightweight. I don't know. But you say the advantage of the stainless steel exhaust valve is what exactly?
It's going to be lighter weight than the ink canal that we use, and it's a very strong valve. It's definitely not a factory valve. It's not hollow. It's a full solid stem valve.
And my understanding is from the GM engineers is that the titanium intake valves are very abrasive. Titanium in and of itself is very abrasive, and it tends to can wear, which is what the issues were with those '06 LS7 heads, is that that would wear on what was it? What would it be touching to wear it out?
So the biggest problem with the LS7s dropping valves, it's a very common problem, is you have valve guides. It's kind of hard to see in here, but the valve guide, the best place that you can look at is this, you'll see a little bronze color in there. We upgrade all of ours to CHE bronze guides, but
That's bronze. Looks silver.
well, you can't really see it. It's going to be, this is all your port. The guide is just right at the very tip. It's what goes into the cylinder head.
Gotcha. Okay, so you were saying about that?
Yeah, so the guide on a factory LS7 head and for the LS7 stuff, the materials are too similar of a material. So when the valve and the guide start wearing against each other, they do an egg-shaped deal to where I'll kind of draw a picture here. So your normal guide is just going to be straight, and then you're going to have your valve inside here that goes up and down. So what happens over time is instead of being straight like that guide should be, you're going to start egg shaped, and this is obviously very dramatic. And your valve comes in here. So now,
That other side.
yeah. So now your valve is going to be walking inside of that in that guide. And so once it starts doing that and your valve starts closing on an oblong angle where the edge of the valve hits the seat instead of the whole entire circle hitting perfectly, that's what happens when you start dropping the valve because it's hitting oblong. So the most ideal thing that we do is we get a different material guide, which is bronze, and it holds oil retention very well. And it wears out at a completely different rate than titanium, and it tends to last a lot longer. So that's in turn what we do to fix those problems on the LS7s.
So bronze guides instead of like the sodium filled ones.
Correct.
And
Well, the guides aren't guides are different than valves. The valves are sodium filled. The guides. Let's go out to the head tail. I can show you what a guide is because it's kind of hard to explain on a fully assembled head.
Yeah.
All right. Of course it's going to be All right. So this is a guide. This is your valve. So this is a factory LS7 titanium intake valve, and this is where it rides in the head. So this piece gets pressed into the cylinder head, and this is where your valve's going to ride. So if you didn't have this and your valve was just sitting in there walking around, you're going to hit the side of your valve. Imagine this is your seat and it's walking around and it hits like that instead of a perfect seal like that.
Yep.
If it hits angled like that, you got to think of 500 pounds of seat pressure pushing on this at an angle at 7,000 RPM. You're going to pop the head of that valve off instantly. So that's why you have to have a very precision machine valve guide. And these are the CHE ones that I was telling you about. They're a very nice guide that works very well. When we hone these, they have really good oil retention. They hold oil inside there very well, which keeps these lubed up, which means you're not wearing things out.
These are the bronze ones, huh?
These are the bronze ones. These are the nice ones. So factory, you're going to have a steel style guide. So this is the upgrade that you want to do on yourself. So
Okay, and so you don't have an example of what the stock and stuff like that.
no, because we don't carry those. We don't want those.
I don't blame you. But those where that titanium, because it's so abrasive, will wear out the factory steel guide.
Correct, and it'll make that egg shape that I was talking about, and your valve will start walking around. The second your valve starts walking around, you're gonna pop the head off of it.
And what drops into the engine?
What happens is it'll break right here, and so it'll come down. And when it comes down at an angle, this whole piece breaks off, and you can just imagine having that drop into your motor. That's
The round part.
the round part, yeah. Your stem usually will break anywhere from here to here, but this piece usually stays in the head, and then this piece will just completely go and cause havoc to your motor.
And fuck up the entire motor. What sounds like what happened, only mine I think is the lifter. Because I mean you can hear the sound, I'll play it for you later, but it sounds like hard metal just clanking, clank,
Right.
you know. So
I got you. So this is kind of our main shop area. We do a lot of manufacturing. So we do front covers, rear covers, time and chain guide, valve covers. I mean, we CNC a lot of product. So this is our cylinder head area. We go through and we do valve jobs. We assemble cylinder heads over there. In the very back, we do CNC porting to cylinder heads. All these are customers that you can send your cylinder heads in. We'll go through, we'll port them, and then send them back to customers. So that's a good process that we do. So this is our shipping area. You can see all these chunks of billet aluminum are going to be turned into something, whether it's valve covers, intake manifolds. It doesn't matter. It'll get turned into anything. So,
solid piece of aluminum.
Yep, solid pieces of aluminum, and our CNC machines will take them down. So you were mentioning that you're going to send your engine in.
Yeah.
So these carts right here are specifically for people that send engines in. We put their name down, their sales order number, and that way we keep everyone's stuff organized. That way we put this number in our system, in the sales order system. We type in your name, number. All we got to do is come out here, find your cart, clean everything up, put it all back together. So that's how we keep really organized and keep over 300 engines at a time in one place.
So this whole cart wouldn't be for one person, right?
No, so this
one section.
This shelf is for one. A long block will usually use probably two, maybe three shelves, but short blocks, one shelf piece.
Okay.
Yep. So you can tell we try and keep a lot of crankshafts in stock. Normally, most of them. All the ones on the bottom are not new, but all the ones hanging up are pretty new. This is why we were able to get your engine done in a pretty reasonable amount of time. Even though you waited a little while, getting the crankshaft that you had, if we had to wait for it, realistically, we probably would have had to wait 6 months.
Really?
So yeah.
Yeah, you hit mine pretty quick. I think
we had it in stock. Yeah, pistons for about 4 to 5 weeks, which is pretty common. Maybe longer than that, but still, I don't remember exactly where we're at on your build. You probably know better than me. I think we're about 10, 12 weeks, something like that.
It was right at about 3 months. Yeah, and I thought that's on me. I wish I had gone with what you initially suggested, like a 1401 or 1301 actual piston. But I didn't think I had 85 anywhere near me, and by the time I found it, the pistons were already here. So they're 12 and a half. So to give me that 13.25, you mill the heads down to increase the compression.
From 13.2 to 14 is not that big of a jump. So you're probably between 15 to 20 horsepower at the most on that. So yeah, I don't think you're going to be having too many issues there. So I wouldn't worry too much about that. 13 to 1 is nothing to laugh at. You're going to be pretty happy with that. So yep. So I'll take you over to our Engine Dyno real quick. That's a big CNC. I'll go into that in a second. That's a story in itself. So of course nothing's on there right now, but this is where we're going to put your motor. We're going to go through. We'll run it through its paces. I can tell you exactly how much power it makes, and it's pretty cool to see how much power. Break everything in.
Yeah, because you'll be using 2-inch headers for mine, I guess, also.
Correct. Yep.
And the and obviously you'd be using 85. What else?
We're going to use C16 here, but
C16.
Yeah.
Is that going to make a difference in terms of it? Because I want to be running 85 because C16 so damn expensive. I can't get the drums.
Yeah. No. It'll be right within the same realm of where it's going to be making power.
The C16 is ethanol, isn't it?
No, it's a race gas. It's 116 octane race fuel.
Gotcha.
Yep.
And I believe 85 is only like what, 106?
I'm not. It's 85% ethanol. So.
Yeah.
Yeah.
I think it was something around 106 octane.
Right.
So your C16 will actually probably make a little bit more power.
Maybe. It's gonna be pretty close to what 85 makes. I'll show you this big machine over here. So some of our newest things that we've been doing is we make our own blocks now.
Yeah.
So this is a billet block. We're going to rate these blocks anywhere from 4 to 5,000 horsepower. So this is for boosted applications, obviously. Um, pretty crazy stuff. There's no way around it. But these are for very big turbos, very big pro chargers, boost blowers, whatever you're trying to do with it. These are going to take some big power, and it's going to be one of the most powerful LS engine blocks ever produced. So,
Wow. When did you start making these guys?
this year we've really started finishing them. We've had this in the works for about the last 2.5 years, but this year we've really gone through and started finishing up R&D and running them. So,
Wow, 5,000 horsepower.
that's definitely on the high end. Most everyone realistically is going to be making around 3,500 to 4,000. But the block itself can handle the 5,000 if you're really trying to push it.
So then, what the supporting components have to be able, like the pistons and the rings and all the things, right? You
Yeah.
have to be able to support that. Are y'all making that?
No, so we just use the best components in the market. So as far as crankshafts, we're going to use Windberg, Bryant, Callie's, any of those billet crankshafts, we'll use those. Billet rods, like we use billet aluminum rods. We're going to use billet pistons from Diamond. Diamond's got a really nice piston for that much power. Total seal rings set up for that application. We have our own cylinder heads that are a racing cylinder head. It's a cannon valve cylinder head. Flows well over 400 CFM, creeping up on the 500 CFM range. So the cylinder heads that we use make just over 1,000 horsepower naturally aspirated. So when the people are running them with boost, they're really making power with them.
Wow.
So
Okay.
yeah, but that's what this machine does. This machine makes billet blocks.
That's all it does is block.
It does a couple other small things. He's working on a pretty specific product, so I probably won't have you film that, but it's all good. These are all old crankshafts that get pulled out. A lot of them are junk, unfortunately. This is a teardown area, so anything that's going to be junk, we're probably going to find it over here.
What do you do with it? You melt it down and reuse it, or?
Yeah, no, we got a scrap guy. If it's junk, we'll scrap it because that's all it's good for at that point. But a lot of them will turn down for used items. Sometimes people want to buy used crankshafts, stuff like that. So
Why would they do? I mean, obviously to save money, but I mean, like, if when a crankshaft goes bad, like, what fucks it up?
So there's a couple of different things that can happen. A lot of times people will spin a bearing. So if you spin a bearing, what you can do is you can get the bearing off of it and you can cut it down. Sometimes you cut it 10,000s, 20,000s, 30,000s. But once you start cutting those down, you start taking away the structural integrity of the crank. So a lot of naturally aspirated combinations are fine to run that way. We really don't sell used cranks for our builds. We just really don't like doing that. We like doing everything new. But we got a couple shops that if they're super interested in a used crank and they know exactly what they're getting, then we'll give them to them at a deal instead of just tossing it in the junk pile, you know.
Can we see what a bearing looks like on one of these, like a bad one?
Like a bad one, yeah. I'll find you one here. No, that's pretty good. So this one's not like bad. This is a pretty mild case. So this one's pretty mild, but you can see how it's different colored right here.
Yeah.
See how it's rainbow? That means it got really hot. So right here you can see it's all different color too. So this thrust bearing actually got pretty spicy right here. That one was right about to get ready to spin. It doesn't look like it actually spun yet. But a lot of times what will happen is the bearing itself will actually clamp on there.
What exactly does the bearing do? And like, what is this? What's it look like?
Yeah, I'll show you. So this is what a bearing looks like.
Okay. Seen those.
Okay, so this is what our bearing is. These are going to be inside your block. You got your main cap. One's going to be inside a main cap. One's going to be inside the block. So you can see inside of here, this is where your oil comes in, and you're going to run on a film of oil. So when you always hear about people calling or checking their clearances, their crankshaft journal size is going to be just a little bit smaller than the ID of this, because you want there to be a clearance in there for your crank to ride on oil. Your crank never should ever touch these. These never are supposed to touch the crank. Your crank is always supposed to ride on a film of oil. That's what keeps these things lasting for such a long time.
Okay.
So when you hear people spinning a bearing or something like that, what happens is for some reason it's not getting proper oiling. So what will happen is it'll quit riding on that film of oil and it'll start riding on this bearing. Once you start doing that, it gets hot really quick. Once it gets hot really quick, it'll literally weld this to the crankshaft, and then bearings will start spinning in the block. Once you do that, you junk your block. Usually junk your crankshaft. It's not a good thing.
The whole block, huh?
Yeah, because you got to think these have tangs in them right here. So once those tangs start spinning in there, you're just eating away that block. And these have crush on them. So when you mount your main cap, these are actually crushed in there. So the second you start spinning that, you lose all your crush. Once you don't have crush, block's junk.
So how do you prevent that from happening?
Proper engine building, proper oiling. Yep. So
that's not a matter of just putting oil in it on a regular basis. It's something that happens early. It's a build process.
Yeah, there's a lot of things that can happen. Like you want to make sure you're changing your oil frequently. Every time you go out to an event, I would recommend changing your oil. It's just you can never change your oil enough.
Okay.
So changing your oil is always a good thing. But yeah, just applications like that, honestly. And then obviously improper setup is probably your biggest thing. But yeah, just change your oil, good oil itself, you know.
And before we leave, I want you to show me what oil you recommend that I use for this motor.
Yeah.
When we're done, before we leave.
Yeah, for sure.
What are these?
So these are the main caps I was talking about. So like I said, the bearing will ride in here, and then that will clamp on to the engine, and your crankshaft's in between it. So that's what holds your crankshaft together.
Gotcha. Okay.
Yep.
Gotcha. And we won't see that on my block because it's already inside.
I can flip it over and show you.
Oh, okay. Yeah, that'd be cool.
Yeah, I can flip you over and show you. Yep. So that machine makes those billet main caps.
Those guys.
Yep. Makes a lot of stuff, but that's primarily what it makes. This is actually going to be an intake manifold. This is the top of an intake manifold.
It is.
Yeah. It's hard to tell because it's not done yet, but just like it goes through the first operation. So this operation's done. They're going to flip it over, mount it, and then they'll go through and it'll machine all this off of it.
Okay.
Yeah. Yep. So this is the second operation. You can kind of see it starting to mill out everything on it.
What's it milling?
Just the aluminum. So
Intake?
yeah, it's the intake manifold.
Wow. Okay.
Yep. So this is doing front covers. So the front cover that bolts onto your motor, this is what it's making.
Oh, and okay, so on mine, like you got the eBay ones for the front engine cover and oil pan. Is that what it was? That was missing. I sent you the link on eBay.
Right.
Is there other than cost, right? Is there a reason to actually manufacture a CNC one?
Yeah, so the ones that we CNC are specifically a VBT delete front cover. So ours has variable valve timing, and what we do is we delete that. So when we delete it, it moves the cam sensor because you have a phaser that's thick. And so when you get rid of that phaser, you're using a thin gear. So when you use that thin gear, your cam sensor doesn't read anymore. So what we do is we make a cover that brings your cam sensor closer to that gear.
Oh.
So, yeah.
What application would that be used for?
Gen 5 LT, some of the older LSs, like your LS7, we don't do it just because it doesn't have it. But, yeah. So your front cover and your oil pan and oil pump all work together. So they have to stay together. You can't really, we don't make any aftermarket for LS7, LS9 stuff. I believe so. I don't do a whole lot of that. I let the builders do that stuff. So this is, you've heard of CNC-ported heads?
Yes.
So this is what we're doing. We're porting a set of heads. This is actually pretty cool because this is the exact set of heads that you have.
Is it really?
Yep.
CIDs.
Yep.
Oh, that's cool.
You can get risky with this one if you want to. This one will open up.
Oh my.
Yeah. Gets a little wet though. So
there's a program. You don't program that yourself?
yeah.
Wow. Oh, that's impressive.
Yep. That's why we get a really good reputation from, because we have a really good airflow CNC head guy. So he goes through and he'll design all these ports for all these different cylinder heads. And he's been doing it for years and years and years. So he's very good at what he does. He designs the ports. He's got programs that he flows them with. He's just really good at what he does.
Yeah.
So, yeah. Same thing with this one. Going through, porting the heads. So, yeah. It's a 5-axis deal. But this is open up here if you want to try and shoot it down.
What's different about these?
So these are a set of LT cylinder heads.
Okay.
Yep.
And by LT, you mean the
Gen 5 LT.
yeah, as opposed to the old C4s.
Well, those are LT4s. So Gen 5 LT stands for LT1, LT4, LT2, and then yours is considered Gen 4 because it's LS. So LS is Gen 4, all the LTs are Gen 5.
But the previous LT, remember the old fourth
Yeah.
generation Corvette?
Yeah, that's small block Chevy LT.
I never understood why they did brought back the LT name, because that's something that was for the fourth generation Corvette.
Yeah,
You
that's a
know?
little weird.
Yeah.
So this CNC is specifically for doing blocks. So what we do with this CNC is we'll go through and we surface both of the cylinder surfaces. So what's good about that compared to a lot of your mom and pop smaller shops is what they're going to do is they're going to indicate off of all 4 corners and then make it flat. So what we do is we have a program that already models a block, and we're going to make them flat. But when we make them flat, they're going to be completely 45-degree angle from what they should be. Blocks should be at a 45-degree angle. So what you do when you put them in a normal surfacer is just try and make them flat. So over time, if you surface it a couple times, you can get 2 surfaces that are completely flat, but they might not be perfect 45-degree angles. This isn't the end of the world. Not going to probably ruin anything, but when you do it with us, you just know it's going to be a perfect 45. So, and not to mention, it streamlines our process. When we do these, we can get a block done in 30 minutes to an hour, whereas it could take us 2 hours just to set up a surfacer. So we're able to get a lot more engines through the process quicker when doing that.
So you would do that to like someone's motor that that sent it to you?
We do it to every single one. Yours was in here. So we go through, we service it, and if we need to, this machine can also bore it. We also do rod clearancing. So with yours being a 4 and a 125 stroke, we'll go through and clearance the block itself so that your rods don't hit the block when it comes around. So a lot of good things like that.
And so when you talk about milling the heads, for instance, to lower the compression,
this machine is what we would mill the cylinder heads with. So as you can see, this is the deck of a cylinder head, and it's pretty dirty. This one has not been milled yet. So this one's getting ready to go through the machine. So when we get done and we mill a cylinder head, this is what it's going to look like. See how it's all shiny and perfectly flat? So that's been through the surfacer. So what we do is we set that cylinder head up on the surfacer and we mount it down, and we get the deck surface to be completely flat, or as flat as we can get it before we start. And then once we do that, this surfacer will go through and will mill across the surface of the cylinder head. And there's a couple reasons that we would do that. One, we want to make sure it's flat. So a lot of times these cylinder heads will have warps in them. Obviously, that's very dramatic because the warps only are going to consist of probably 2 to 5 thousandths at the most, as far as that goes. But we'll go through and make sure that they're perfectly flat. That way, when they go onto the block, it's also perfectly flat. Everything seals as it should. That's what this machine's for. Sometimes we want to raise compression in this chamber. So I'm sure you've heard of chamber volume before, or CCs of a cylinder head. So this portion right here that is cut in, this whole entire area, is considered your chamber volume. So what you do when you start milling this, is you start making this chamber volume a smaller size. So the volume of it is going to be less. So the less chamber volume you have, the less room you have for your combustion. So in turn, what that does is raises your compression ratio. So you have a lot more compression because there's less room for the combustion to happen.
Less room because okay, so you're literally taking metal off this.
You're taking metal off this, making this smaller. So that's why people, you always hear, I want to mill my heads 20 or mill them 30 because it's going to be taking the chamber size smaller, raising your compression.
How do you know the limits, like of how much you can mill? Like there's this, imagine there's just so much you can mill before you fuck up your heads, right?
Correct. And that's why going to an aftermarket head is so nice because this deck surface is so much thicker. You have a lot more to play with there. On factory stuff, we have a measurement. You can go from the head bolt hole to here. Don't ask me what it is. I don't know. Cylinder head guys will know that. But they can tell how much a cylinder head has been decked and serviced before. But generically, from a factory set of heads, you don't really want to go more than 30 thousandths. After you go more than 30 thousandths, you got to think this is going to be moving the cylinder head down. In turn, moves your intake bolt holes out. So when you to move them in. So what happens is your intake does not want to bolt up correctly anymore because you've milled so much. It changes the geometry of everything. So we usually only go 30 thousandths. That way your intake's still good to go.
And that's on a stock head.
Stock head, yep. You can still go more on an aftermarket head, but again, you're still going to be running into the geometry problems. So a lot of times what we'll do is we'll go through and mill the intake depending on what intake it is, just to try and get everything to fit right. But ideally, if you just order the correct pistons, you don't have to do all that horse around. You can just set it all up correctly and be good to go.
And in my case, because I didn't get quite the right pistons from an order, right? Because they really should have been like 13 or something, or 14. We had to mill my head some, right?
Correct. We didn't mill them enough to worry about any sort of intake fitment. So.
And you mentioned having to mill the intake because of the geometry?
The intake holes, like on your intake, we would never mess with that. With it being plastic, is what it is. We're not gonna mess with it. But say it's one of our billet intakes or another customer's sheet metal that we can go in there and mill out the intake holes, we'll do something like that. The plastic one, not touching that.
Where are the intake holes?
These right here. So this is where your intake bolt holes are gonna. Yeah. These are the guides that I was talking about.
Oh yeah, I remember that from my last set of heads. So these are the bronze ones, right?
Correct. Yep.
Which is what we saw before earlier.
Yep.
Okay. And then the intake, where are the intake ones? Would they be on here? The titanium ones?
There's no valves in there. This is just a bare head.
Okay. But okay, I got you. And so the intake valve is titanium. That's going to go here. The exhaust is stainless steel. That goes in there.
On an LS7, yeah. These are LS3, so a little different, but yeah.
Okay. Now I'm with you.
Yep.
That makes good sense. Okay.
So that machine that I was telling you about that does all the surfacing, it also serial numbers every block that we work on so that we can know all the information about it. So remember how I was telling you that machine does rod clearancing? Mm-hmm. So see this piece right here, and then you can see where it cuts out right here. That is going to be clearance for your rods coming around for the bigger stroke. So that's all the clearancing that we do.
The rods are here.
Yep, so your rods are here, but when they turn around, they're going to get close right here. That's why we clearance it out, so that nothing hits.
Okay.
And then you can see that we weld our reluctor wheels on the crankshaft, just to make sure that nothing ever spins on here. That's been problematic on factory build. So we always weld those on, make sure they don't go anywhere.
What are those two things?
So this is your reluctor. This is
Reluctor.
reluctor wheel. Yep. Your camshaft sensor comes in right here, and this is what reads where your engine's at. And that's how your computer knows where your engine's at and control your timing.
I gotcha. These aren't normally welded,
Not from factory, nope.
Really?
They're pressed on steel. Yep.
so that's the point of failure then. Huh?
Yep.
Does that happen much?
Yep. Yep. That's why we do it. It's more common in the blower applications, but it's happened in any sort of high RPM application. So it's just standard procedure here.
Gotcha. And the cam bolts, what are those?
You're not in yet because you haven't put your gear on yet, but that's these. So we use an ARP cam bolt. That's the highest grade bolt that you can use for a camshaft. Yeah.
Gotcha. And those go in here.
Yep, right into your cam.
Gotcha. And the cam's already in?
Cam's in it. Yep, just we haven't put the time set on yet.
Gotcha. I think you already sent me the cam spec.
Yeah, we have that. Yeah, we use ARP for everything. Main fasteners, head fasteners, rod fasteners, cam, everything gets ARP. So
That's awesome, man. That's awesome. So, heads go on today, I guess, and then sometime next week, the engine dyno.
yeah, realistically, the heads will be going on Monday.
Right.
They're pretty much done on it this week. Just we've had some builders had to hop out just for some family emergency stuff. So, yeah, Monday we'll be getting these things on the dyno. I don't know if it'll be on the dyno, but maybe Monday, Tuesday.
Yeah.
So, but it'll be a long walk by Monday for sure.
So how long do you run it on the dyno to like break it? Because traditionally they tell you 500 miles, right, of break
Right.
in and before you can like get on it. How do y'all?
Yeah.
What's the process for you guys?
So when we run it, we're going to go through and we call it driving it around. So when we go on the dyno, we have a servo on the dyno that we can turn up the load and vary it. So we go through and we'll vary the load because what you're trying to do is seat those rings. You want the rings to be seated with the cylinder wall. It's about the only thing in these things that really need broke in anymore. All the older engines, you needed to break in to flat tap it. Lifters and stuff, everything on these are rollers. So you don't need to break in any roller stuff. But we do like to try and seat the rings. So anyway, we'll go through, drive it around for 30 minutes or so, just getting everything all set up and working. And then after that, we'll go through and we'll do baby pulls. We start pulling it up to about 4,000. Then we'll go up 500 RPMs at a time until we get to our final pull, which is usually around 7,500 to 8,000. So it equals out to be about 12 to 14
12 to 14
pulls.
oh, okay.
Yeah, so we'll go through and at the very end we have a blow by meter to show you how much blow by it comes from us. Shows your oil pressure. Just shows the whole vitals of the engine, just to kind of give you proof of what we built you. So.
And that's the final pull where you test the horsepower and all that stuff.
Yep. The final pull usually generically be the highest. Usually the last one, second to last one, something like that.
Very cool. And then you ship it. That's awesome.
It should be there in a day.
Really? Okay.
Yeah, usually a day shipping anywhere, big city like Austin or Dallas. Yeah.
Put that in and probably take them. I know I got a bill for him already. Like 30 hours for engine swap.
Right.
So it'll probably take them a good week.
Yeah.
So if it ships next week, then the week after that, probably the third week of August is probably when it'll come together.
Yeah.
Everything else should be in. My engine hood should be fully painted by then, and you already have the intake manifold but I think everything else, I'm pretty positive everything else will be in by then. So.
Perfect.
Great. Thank you very much for the tour.
Yeah,
and,
absolutely.
Can't wait to get this edited and loaded to the channel and give you guys some business. Yeah, I was gonna say you don't need the business, but everyone can use more business.
Always.
So
Always, for sure.
that's awesome. Well, thank you, kind sir. I really appreciate the tour. You
Yeah,
taking the time out,
absolutely.
letting me film and everything.
Yeah, for sure. Glad to have you here.
Absolutely. Right.
All right, that was really awesome. Colin hooked me up with a little merch. Got a couple of shirts I'll be wearing on the channel from here on out. That's for sure. I really am stoked about getting this motor. Finally, have a reputable engine place building the entire freaking thing, soup to nuts. These guys over at LME are freaking awesome. They allowed me to video this for my channel. I really hope to pay them back with, just the generosity and just taking the time. I know these guys are busy, took some time out of their busy schedule. So, you guys need some engine work, head work, whatever, come here. These guys are awesome. They're in Houston, Texas. You don't have to live here. I don't live here. They treated me like gold, and yeah, they do good work. So I'm really looking forward to seeing how much power this motor puts out. I'm looking forward to getting it back to me in Austin. Take probably a couple weeks before it's in the car. I got my ported MSD intake from Tony Memo with the stupid shaved letterhead wiped off. I can't stand that raised MSD letter. But Tony got that to them. So looking forward to putting down some power. Pat G is going to be doing the tuning. Stay tuned for that video. Yeah, I'm going to head back to Austin here in a bit. So ending with, as always, PSA on PSA. Do yourself a favor, get your yearly physicals, have that doctor check that PSA box on your blood form. No reason to not have it checked. Get ahead of that prostate cancer. I think we'll all end up with it at some point. Doesn't mean you die from it. So please, always, always, always get those physicals and have that doctor, please, check that box.
Save your tears for another day.